Welcome to the lesson on Vernier scale. Upon completion of this lesson, learners will be able to analyze measurement readings using Vernier scales to accurately interpret both English and metric unit values and explain the systematic measuring process using a Vernier scale. The Vernier scale, invented by French mathematician Pierre Vernier in 1631, is used as a visual method of subdividing the smallest divisions on a scale for more precise measurements. Using a Vernier scale allows you to obtain more precise measures than a uniform straight or circular scale. These scales are used in navigation, surveying, and in manufacturing. Understanding how to read a Vernier scale will help you in using both a Vernier caliper and a Vernier micrometer, two commonly used precision measuring tools. Other precision measuring tools that utilize the Vernier scale include the Vernier protractor and various surveying devices. All Vernier instruments have two scales, the main scale and the Vernier scale, both of which have English and metric units. The Vernier scale is a sliding secondary piece that is more finely graduated than the main scale, thus allowing for increased accuracy of reading. The picture you see here shows an example of the main scale and Vernier scale on a caliper. On the main scale, Pierre Vernier divided each inch into 10 parts, or tenths. He then divided each of the tenths into half, or 20ths, and then half again into 40ths. On the Vernier scale, each 40th is further divided by 25, thus having the ability of being precise up to 1/1000th of an inch. Similarly, for the metric system, on the main scale, Pierre Vernier divided each centimeter into 10 parts, or tenths. On the Vernier scale, each tenth is divided first by 10 and then by 2, thus having the ability to be precise up to 0.005 or 5/1000ths of a centimeter or 5/100ths of a millimeter. Understanding how to read a Vernier scale will help you in using both a Vernier caliper and a Vernier micrometer, two very common precision measuring tools. Other precision measuring tools that utilize the Vernier scale include the Vernier protractor and some surveying devices. Here are 6 steps that experts follow in reading a Vernier scale. Each of these steps will be described in detail in the next few slides. Let's use the Vernier scale shown here to work through the 6 steps of reading a Vernier scale. The first step is to determine which measuring system you should use. It is important to get into the habit of knowing what measuring system you want to use and which is shown on your instrument. In this case, the measuring system being used is the English system, and the unit of measurement is 1 inch. A clue is the marking on the lower right-hand corner of the scales, which reads 1/1000th of an inch, which tells us we are measuring in inches and using the English system. The next step is to find the major reading. The major reading corresponds to the smallest of the 2 unit measures in which the 0 of the Vernier scale lies. In this case, the Vernier scale lies between 0 and 1 in. Therefore, the major reading is 0.000 in. The next step is to find the minor reading. The minor reading is also found on the main scale, and it corresponds to the smallest of the 2 tenth measures in which the 0 of the Vernier scale lies. In the case seen here, the Vernier scale lies between 8 and 9. Therefore, the minor reading is 0.800 in. The next step is to find the subminor reading. The subminor reading is also found on the main scale and is found by counting the graduations after the minor graduation but before the 0 of the Vernier scale and multiplying by 0.025 inch. In this case, there is only one graduation between the 0.8 inch graduation and the Vernier 0. Therefore, the subminor reading is 1 x 0.025 inch, which equals 0.025 inch. The next step is to find the Vernier reading. The Vernier reading is the only reading found actually on the Vernier scale. The Vernier reading is found by determining which of the 25 graduations on the Vernier scale aligns perfectly with the graduation on the main scale. In this case, the 8th graduation on the Vernier scale perfectly aligns with the graduation on the main scale. Therefore, the Vernier reading is 0.008 inch. The final step to reading a Vernier scale is to add up all of the previously found readings. The purpose of the major, minor, subminor, and Vernier readings is to deconstruct the measurement. In order to obtain the precise measurement, add all the readings together. In this case, we add up 0.000 plus 0.800 plus 0.025 plus 0.008 inches. Together, they make a measurement of 0.833 inches. Here is another Vernier scale. Let's read the above measurement using the 6-step process. First, the measurement system depicted is the metric system, and the unit of measurement is 1 centimeter. Second, the major reading is 2 centimeters, as the Vernier 0 lies between 2 centimeters and 3 centimeters. Third, the minor reading is 0.100 centimeters, because the Vernier 0 lies between the 0.1 centimeter and 0.2 centimeter graduations. Fourth, there is no sub-minor reading because the main scale is not subdivided beyond tenths. Therefore, we can proceed to the Vernier reading, which is 0.015 centimeters. Fifth, the Vernier reading aligns with the third graduation after the Vernier 0, with each graduation equal to 0.005 centimeters. Lastly, now that we have all the readings, we can add them together. In summary, a Vernier scale allows you to measure objects with great accuracy by hand. Understanding how to read a Vernier scale makes it easier to use precision tools like Vernier calipers and micrometers. By following a simple 6-step process, you can accurately take measurements using the Vernier scale for both English and metric units. Thank you.